Now, the second session will also have some 3 presentations. It will be moderated still by Dr. Kerry Senior. Let me request Dr. Kerry to take the floor. Thank you very much.
Thank you, and thank you all for participating in the exercises. Hopefully everyone's relaxed and revitalized. In this second session, our speakers will be addressing the topic of recent advances on leather development, processing and sustainability. And I think we can agree that the importance of this area cannot be understated. Further to the point suggested in our first session, our customers continuously look to us to improve how we make our products and to demonstrate that we're doing this properly to them. So as such, I'm very pleased to introduce our 3 speakers who have huge experience in the fields of sustainability and innovation. Again, I shall give a brief introduction to all 3, and then hopefully at the end we'll have some time for some questions and answers. As noted, if there are any questions, please just put them in the chat box. Our first speaker is Mr. Kim Senna. Kim is currently Sustainability Manager for JBS Chorus, with a background in process engineering, process optimization, and research in the leather industry. He was one of those responsible for the design and creation of Kind leather. He has also worked on the development of supply chain transparency and traceability interfaces for JBS 360. As part of a vertically integrated business, he is engaged with connecting with the demands from consumer-facing brands to sustainable cattle raising practices. Today, he will be speaking about a science-based approach for the reduction of leather's environmental impact. Our next speaker will be Mr. Rogério Cunha. Rogério is the Trade Intelligence Manager for the Center for the Brazilian Tanning Industry, CICB, and the spokesperson for the Brazilian Leather Industry Sustainability Certification Scheme. With an MBA in Business Management, specialization in foreign trade and international business, and a bachelor degree in administration, he has worked with foreign trade for 30 years, acting as a Director of International Affairs and Export Department Executive in international companies, and with commercial experience in about 50 countries. Today, his topic is the leather value chain and sustainability as an industry driver. And our final speaker in this session will be Mr. Vikrant Pratap. Vikrant is the CEO of Qualys, a UK-based company that provides a patented technology that helps tanneries lower their environmental footprint while reducing their production costs and improving the quality of their leather. Vikrant has led Qualys since 2016, overseeing the development of the business from early trials through technology readiness level 9 and onto commercialization. Prior to joining Qualys, Vikrant worked on commercializing disruptive technologies across multiple sectors, including banking, education, mobile commerce, and social media platforms. He also worked as a management consultant with McKinsey & Co., advising clients worldwide on strategy, operations, and finance. He holds a Bachelor of Electronic Engineering from Cooper Union in New York and an MBA from INSEAD. And today he will be discussing practical solutions for deploying polymer sphere technology at production scale. But if I'd like to hand over now to our first speaker, Mr. Kim Senna from JBS. Over to you, Kim. Thank you.
Thank you very much, Kerry. First of all, thanks to all the organizers for the invitation and for putting together such a great event with such great discussions. Thank you also to all the attendees. Let me share the screen quite fast. I'd like to begin with a reflection of what actually makes a sustainable material. And as you can see, it's on purpose. We are not talking specifically about leather here, but of materials in general. So raw material extraction, of course, we have to do it responsibly. We have to do it with traceability to guarantee that there is minimal impact to biodiversity and to the biosphere as a whole, with the farming practices, textile production, of course, if not handled well, chemicals and energy used in the production or waste, you can deal very big environmental damage. But of course, the production can harm communities and people if it's not done socially responsible, in a socially responsible way. Of course, that chemistry, many segments can have toxic chemicals, and we have to address that well to guarantee minimal externalities with local communities. And of course, the end of life of the material is a problem worldwide. Material value chains have been designed to be linear and not circular, and now humanity faces this challenge to shift value chains from linear to circular. And of course, there are several other complications and several other topics we have to address when looking at these four pillars, let's call it this way. And there are tools to address the environmental impact of material and to, well, focusing on comparability and on having the same framework for all the materials. And as we'll see, it's not always like that. That's the idea behind it. But the life cycle assessment methodology, it looks to provide the same basis for comparison of different production systems and compare the overall environmental impact of this material within different impact categories. So as we can see here, it can be global warming potential, but it can be water scarcity. So this tool, the Higg Material Sustainability Index, it provides a way to compare. So designers and anyone working with sourcing materials can look at that from that point of view and manage it and decrease the environmental burden of a given value chain. But as we can see, when we look at leather here, global leather, in this score being the lower, the better for global warming potential, it's not really well seen. And we have put some work together here on repositioning it. But again, when we look at, when we did this and we started learning from it, we learned that, well, one thing was the environmental efficiency of the product we were assessing. That's one point. But there was also one other really important point, which is the calculation for leather globally as an average is not fair. It's not, it lacks high quality data. It lacks, well, to be updated and to actually reflect how leather is as a material, as well put in by the organizers of the event. A gift from nature, it is a byproduct, and if done with responsibly, it is the ultimate circular solution, right? Using a byproduct of a different industry as a raw material for another one. When you look at all the discussion of bioplastics, that's what they say, right? I mean, to produce bioplastics, if you have to farm the raw materials, you will deal some impact. The ideal approach would be to use byproducts of the agricultural system to produce bioplastics. That's what leather does ultimately, right? And again, just here one other example of how leather is shown here. So it's really not a good image, and we have very a lot of people doing hard work in updating these values. The process is complex, but it is important because that's how leather is seen by whoever is looking at this quantifiable metrics. And when we look at the data and we start analyzing it, we start getting some very, we start getting worried about how the results are put together and how they end up being what they are. So if we look at eutrophication, for instance, which is one of the impact categories a life cycle assessment can provide, and we look at the impact per stage, and as we can see here, the orange part of the bar, which represents 80% of the overall impact of eutrophication, is from upstream processes, from farming practices. Eutrophication here being excess nutrients such as phosphate being sent to bodies of water, accelerating microbial and algae activity, and then depleting oxygen in that body of water, killing all life. So it's an important impact, and as you can see, 80% of it is attributed to the animal farming and not to leather processing, tanning, beam house, post tanning, and finishing. It's only the other 20%. And as we can see for other impact categories, such as global warming potential here, the GWP, the second one, 50% of it is from cattle farming. If we start to dive deep into this, we can realize that here there's the whole concept the IPCC uses for global warming potential, which is by calculating an equivalent global warming potential between gases to CO2, right? So if an animal is belching and it emits methane, it will, the amount of the impact of methane to global warming will be calculated to get back to a single unit, which is CO2 equivalent emitted per square meter of leather. The problem here being that methane is not CO2. CO2 stays for more than a century in the atmosphere, while methane is oxidated in a decade, in 10 years. So one is a long-term gas, the other is a short-term gas, and they react totally different in terms of how they add up to global warming. But that put aside, the message from this plot being that the impact of upstream processes of cattle farming is way too big for leather, and it has to be addressed. If you look at this other plot, still, well, we started working on several other LCAs for several other articles in different segments, automotive, upholstery, leather goods, athletic shoes, and we started seeing that the impact varies a lot from article to articles, and we started making questions about that. So for upstream processes, we can see the orange bar is different from different articles, but also the other bar, so post-tanning, the impact can vary a lot. So we started making ourselves questions on what is the impact of the chemistry of that is being used to produce this specific article. What is the configuration of the value chain? So this plot, it might get a bit confusing at first, but I mean, it's in the different facets, you can see the upstream impact and how it's distributed, the beam house impact, the tanning impact, and so on. But as we can see, so let's say transport, the blue bar, and tanning. So the impact of transportation to global warming potential during the tanning stage can vary a lot. So it can be 3-4 times bigger in one article than the other, depending on the supply chain configuration worldwide. This is an example. Electric energy, the impact of the sources of energy, if it's hydroelectric power, coal power, or nuclear power, can impact a lot in the overall impact of leather. As we can see, of course, the upstream impact is way too big, but if we focus on what we can do at first as a tannery, we can learn a lot from these processes and tackle the right things. But again, allocation is of utmost importance. It's a challenge though, because not a lot of data is available on different farming practices, and the allocation, it has a well set aspect where it's the impact of the animal is allocated to the rawhide and to leather through economic and mass criteria and mass allocation. And this is done in a way that, well, 0.8 to 3.5, that's the average nowadays, of the total 0.8 to 3.5% of the total impact of the animal is allocated to leather. We can get into a discussion here of leather is a byproduct, and talking about bovines here. Bovines are not killed for leather, but for meat. But when we talk about the methodological framework that was put together for it, this is the way that it works. So, I mean, that would be a discussion to have regarding the methodology and not about conducting an LCA itself, where you have to rely on using the proper allocation factors. And what we are doing now as a company is we are promoting a competence center, which is not yet created. We are announcing the first time here in a public event. We are putting together the proper law aspects and technical framework, but the idea is we as a company are just promoting it. So we are promoting it, putting together some money, but also inviting other specialists. There's a technical company, a technical specialist, which will conduct this competence center. But what it will be a pre-competitive, open to all interested parts, so companies, academia, NGO, industry associations, or whoever wants to join it. The idea is to provide a technical environment to gather data and discuss proper allocation to leather. So we have a fair basis allocated to leather itself. And this will evaluate different geographies, cattle breeds, feeds used for animals. As we know, some feed types can actually decrease methane emission, and factors like that to provide better numbers for leather. And then in the future, the idea is to expand to biomaterials also, other biomaterials, since many of them face the same challenges as leather in terms of allocation. We can also understand better how chemicals impact, so we can get the impact per chemical in these LCA results, and understand which chemicals can we replace, what can we do better in the different impact categories, and make proper decisions. So if someone provides a new chemical to us, offers a new chemical, or we are researching and a new chemical shows an alternative for decreasing environmental impact, we can look at its impact in terms of life cycle assessment impact, together with the MRSL, right? So the toxicity of that chemical, and assess if it's really going to provide the benefit in reducing the impact and with guaranteeing MRSL compliance to achieve a better result in this development, in this article. If yes, we can continue with technical and economical assessment, or we could stop the process. This also gives us a very good framework for improvement. So this is what an approach like this can provide to us. What if analysis, so we can ask ourselves, if we replace this, if we use that, is it going to improve or not? We can look at the hotspots from an analytic point of view, and look at what to improve also, and then go to a continuous improvement cycle. I mean, it's easy to put it this way. Of course, we are learning from this process. We are learning what to look at. We are learning how to do this efficiently. So we are very excited for the medium term to get real results. And when we talk about waste and end of life, we can always, of course, start by reducing, right? Before dealing with the end of the problem, which is then having to find a circular solution for what you can't reduce. And when we look at reduction, one of the best ways, I mean, for everything, I suppose, is to use design. So usually they're simple concepts, but they provide very important solutions. One thing that we are doing through our platform, Kind Leather, but here it's not a question of brand, it's more a question of a good approach, a good design approach to a problem, and that can be, I'm sure we will see in the future in many, being done by many others, which is to remove in the beginning of the process the parts of the hide that we know that are going to be thrown away, statistically no, right? They're going to be thrown away while cutting and assembling. So then you can really increase cutting yield, reduce waste generation, and tackle this problem, which is true for all, well, most of the materials worldwide. Again, linear supply chains, no circularity thought of in the design part of the process for any material, so we can reduce waste generation. And so to sum up here, I mean, when we look at a cradle-to-cradle philosophical approach to and practical approach to producing materials for the garment industry, we can look at the biological cycle, which is where leather comes from as a byproduct, and a technical cycle, which is where synthetics would come from the beginning. Leather starts in the biological cycle, but it can shift to the technical cycle due to metal tanning or other practices. We use, of course, PU for coating, and that can make leather not 100% a biological material and then a technical material. There are ways to shift leather back to the biological cycle, such as co-processing and other solutions that face challenges in terms of economical viability, but they're already there and they're technically available. So depending on supply chain configuration, it can get expensive or not, but there is a solution. But when we get to the final product, we still face a lot of challenges. Well, the leather sector is not particularly intensive in R&D investment, in research and development. Of course, we have to improve on that. But the thing is, we have to find new solutions for leather circularity. We have to find solutions for a material that has everything to work in agreement with a material of the future. And when we look at this PU coating, of course, whenever we get a material and we blend it together and we create what we can call monstrous hybrids, which are the mix of many materials together, we make recycling harder, right? One example is a milk can where you can see a milk bottle where you can see metal and paper and all put together. Then how do you recycle that, right? And in the end, that's also a question for us to make. So use leather and minimum of other materials to guarantee recyclability options for the future, for the end of life of that material. That is true, of course, for any other material. But the message being that leather starts and can end in the biological cycle. Researching new solutions is, of course, something companies like, well, all the companies worldwide and industry associations have to put effort together to find solutions. This is it, everyone. I would like to thank all of you for the attention. Really, my contact is here if in case anyone wants to discuss any further. And of course, I'll be available for the Q&A here. Thank you very much.
Thank you very much, Kim. Absolutely fascinating. And great to see some real progress being made in this area. I'd now like to hand over to our next speaker, Mr. Rogerio Cunha, for his presentation. Thank you.
Hello, everyone. I'd like to thank you to the Africa Leather and Leather Products Association, all organizers of the World Leather Congress, for the kind invitation and opportunity to show everyone the Brazilian leather industry with the direction about our developments toward sustainability. I'd like to make a special thank and best wishes to the president and mastermind of the Congress, our colleague and friend, Mr. Winnie, and also to the Professor McConnell. Thank you very much for this invitation. I'm going to talk today. I'm going to share my presentation now. I'm going to talk today about the leather value chain and sustainability as the industry driver. So I'm representing the Center for the Brazilian Tanning Industry, and I'm responsible for the Trade Intelligence Department and for promoting the CSCB worldwide, the Brazilian Leather Sustainability Certification. CICB is an entity with more than 60 years that represents the Brazilian hides and skin industry. I want to start by showing you the profile of the Brazilian leather sector, where we currently have 244 leather production units owned by 207 companies. Among them, there are 160 exporting companies and about 32,000 workers who generate an annual turnover of $2.5 billion US. We export $1.5 billion US with a positive trade balance of $1 billion every year. The Brazilian cattle herd is more than 220 million heads, with a slaughter of 40 million heads per year, which is considered the largest commercial cattle herd in the world. The production facilities in Brazil are spread into 23 states, with the greatest concentration in South, Southeast, and Center-West of the country. As you can see, these stronger green color states are the one with the highest number of tanneries, South and Southeast. The export destinations are mainly the countries in Asia, where China's share is 31.2%. Then we have the United States with 17.5%, Italy with 16.1%, and then we have Vietnam and Germany. These are the 5 main destinations for our exports. We really would like to expand our exports to Africa, which today represents less than 1% of value and 1.3% in volume. So considering sustainability, it is important to know that Brazil has the largest number of tanneries with sustainability certifications in the leather industry. More than that, Brazil is one of the only countries in the world to have its own robust certification. As you can see, our certification has the tripod of sustainability with economic, social, and environmental dimensions, being managed by sustainability itself. The CSCB is supported by government agency and it is audited by third parties, which therefore are exempt from any interference with the certification. The certification has a B&T standard. This standard is called Leather, Principles, Criteria, and Indicator for Sustainable Production. The CICB is therefore a promoter of the CSCB. We support companies to be certified. Through Inmetro, the CSCB is internationally recognized by a mutual agreement with the IAF, the International Accreditation Forum, and also the ILAC, which is the International Laboratory Accreditation Corporation, which guarantee accreditation for CSCB. This scheme started in 2013 with the purpose of being a reference in the country's leather industry. It was a necessity in a country which exports most of its production. It was created in a tripartite committee among producers, customers, associations, universities, NGOs, suppliers, among others. Among the main items that we believe are relevant for this certification, we can mention that Brazil has the largest commercial cattle herd in the world, being therefore one of the largest leather producers, also participating as a major supplier of raw material for the industry, as well as having a cutting-edge technology know-how in the leather production. Furthermore, sustainability is increasingly valued and perceived by consumers when they purchase a product, and it is with no doubt a very relevant aspect in today's business with growing concern for the future of our planet. Therefore, considering all these factors, today to enter or remain in the market, a sustainability certification has become a need that we all have to consider. Among the goals that we can mention, we increasingly want to promote the best sustainable production practices, which represent gains for those who have the certification and for those who value the product. So we can define that the requirements of a truly sustainable leather, where the same requirements can be transferred to the product of the entire value chain. Now looking to the details of the certification, we can say that it has principles, criteria, and indicators. These principles are the reference for the sustainable leather production in each of the 4 dimensions. So we have sustainability management, which encompasses the other 3 pillars: economic, environmental, and social. Unlike some certifications for the sector, which are only environmental, the CSCB has this tripod. The truth is that we don't just want to put a seal on the product, but rather improve processes, the environmental, and apply sustainability concepts in all areas of the company. The attribute creates everyone engagement with the best production practices, allowing for financial, environmental, and social gains for the company, customers, and employees. And the criteria describe sustainability practices with the specific indicators, which can be quantitative or qualitative. There are more than 150 indicators. Companies can be certified at 4 levels. The first one is bronze, when it hits 50% of the indicators. Then we have silver, with 75% of the accomplished, and then gold with 9%, and then we have diamond with 100%. These percentages must be achieved in each of the certification pillars. All the details of each dimension are on the CSCB website, which is cscb.org.br, cscb.org.br. We have the complete CSCB booklet on the website. So getting to the end of my presentation, this chart is very important. In this initial assessment of companies, the achievement of the indicator is always very low, where you can see the average in each of the 4 dimensions. In management, the initial average assessment is only 14%. In the economic and environmental dimension, it is where the best average are, but it's still only 41%. Then comes the social with 22%. With the preparation of the Tannery's, companies identify new practices, look deeper into the process through a critical analysis of the aspects that must be worked on. The companies raise this average to at least 50% in all dimensions with the bronze seal, and then promote incredible gains for everyone. So this is the CSCB and how we can improve our industry, our sector, to have a future of prosperity and evolution through sustainability. Here you have my contact email and the CSCB website. Thank you all, and I wish you a great Congress. Thank you very much.
Thank you very much, Rogério, for that insight into the CICB Sustainability Program. Our next speaker is Mr. Vikrant Pratap of Qualys, who will be speaking to us on the subject of practical solutions for deploying Polymer Sphere technology at production scale. Are you there, Vikrant?
Well, thank you for the introduction, Kerry. And my name is Vikrant Pratap. I am the CEO of Qualys. First of all, let me wish all of you a very successful conference over the next few days. Regrettably, I can't join, but hopefully we'll get a chance to see many of you at some future events. And thank you to the organizers of World Leather Congress for giving me an opportunity to present today. The title of my presentation is Practical Solutions for Deploying Polymer Sphere Technology at Production Scale. And I think perhaps the first place to start is, what is polymer sphere technology? And perhaps some of you have come across the polymer sphere technology over the past several years, or have heard about it for the past few years. But let me start with, what is it? So polymer spheres are small polymer-based spheroids. You can see an image on the screen. The shape is somewhere between a sphere and a cuboid. For simplicity, we just refer to them as spheres. And the essence of using spheres in production is that they replace a significant percentage of the water in the retanning and dyeing process, so to convert wet blue or wet white into crust. And the benefit of using spheres for production is that they are very efficient in helping to deliver chemistry into the fiber structure of the hide. So they help to deliver chemistry more deeply into the fiber structure of the hide and more uniformly across the surface of the hides. And of course, by replacing large quantities of water, that reduces the amount of water that's required for the production process. And by delivering the chemicals more effectively, the chemistry ends up where it's intended to go, into the hide itself, and less going out in the wastewater and the effluent. And that's the essence of the benefit of using spheres. The spheres themselves are inert so that they can be used with a broad range of chemistries. Tanners don't need to change their existing chemical formulations in order to use spheres. The existing formulations apply, just the chemistry is delivered more effectively. And the spheres can be reused after each cycle for hundreds of cycles. At end of life, typically we expect, typically for most tanneries, between 12 to 18 months, they will need to be replaced. And at end of life, they're taken away and recycled into other materials or into new spheres. So between 2015 and 2018, demonstrations were conducted with multiple tanneries in the automotive and the footwear and luxury goods segments. And through those demonstrations, it was proven that on average, the chemicals such as dyes, fat liquors, and retanning agents can be reduced in the automotive sector. You see the results on your screen by about 11 to 12%. And water in the retanning process can be reduced by, on average, about 39%. Now, of course, that varies from recipe to recipe, but these are average numbers here. And similar levels of reductions can be achieved for footwear and handbag applications. Dyes, fat liquors, and retanning agents typically reduced by about 13% and water by about 37% through numerous demonstrations conducted in Europe and North America. So between 2015 and 2018, the core benefit of applying spheres for retanning had been proven through a broad range of demonstrations for a large range of leather articles in numerous tanneries. And then once that was done, then the challenge became, well, it works in small scale drums. It works in isolated demonstrations in production scale drums, but how does it actually work in practice, right? It's one thing to do a one-off trial or one-off demonstration. It's another thing for tanners to be able to use this new technology in a full production scale day after day after day. And there are some challenges with doing so. So from 2019 onwards, there was a lot of work that was done to address those challenges. And those challenges were typically of three sorts. First, how will this handling of spheres work in production? It's fine to do a very controlled experiment or a controlled demonstration one-off. It's completely different to be using tons of spheres for full production day in and day out throughout the year. How will that work? Second, is implementation of spheres commercially viable? So does it make sense for tanneries to switch from the current, or let's say traditional mechanism for producing or retanning to a sphere-based mechanism for retanning? Is it commercially viable? Is it economically viable? And then finally, what impact will it have on the operations, and will they be able to embrace this new system for working? The rest of this presentation will focus on these practical considerations, mostly on question number 1, and then towards the end on questions 2 and 3. So how do the spheres, how can a tannery handle the spheres in production? Now, tanneries come in many different sizes and configurations, as you know, from those handling a few hundred hides a day to those handling many thousand hides a day. And so how will the handling of spheres work in those different environments? And to allow for the spheres to be used in a broad range of tanneries, a system needed to be very modular so that it could be configured to the specific needs of each tannery. And that modular system consisted of 5 components. 1, there was need for some mechanism for storing the spheres. 2, some mechanism for dosing them into the drums at the right time. 3, for containing them inside the drum throughout the cycle. 4, for separating the drum from the hides at the end of the cycle. And then 5, for cleaning the spheres, separating from the small fibers and stringers that are in the final bath, so that they can be put back into storage and reused again for the next cycle. And now I'll take you through some of the solutions for each of those 5 modules. First, storage. Storage of bulk quantities, it's a solved problem that's been addressed in many different industries, and it's a relatively straightforward, low-cost solution that's available for tanneries. In the middle of the screen, you see a silo. That silo can be configured to be of varying different sizes and scales. And on the right-hand side, you can see a modular system that uses smaller 1-ton bags or containers. Either option is viable. The key is at the right time, here on the screen on the left, you can see an operator pressing or requesting the right quantity of spheres. They're then discharged by the silo into a container underneath that you see on the screen over here, and the right quantity is available for dosing into the drum. Similar mechanisms available if a bag-based or small container-based solution is used, where the spheres are stored in those individual containers. Once they're, the right quantity has been discharged from the silo into the dosing container, very simply, a forklift can lift that container, position it above the drum, and an operator then just presses a remote operated opening of the door, and the spheres are discharged into the drum at the right time. Now, that is a very simple, low-cost mechanism that tanneries can use worldwide. But equally, if a tannery were interested in an automated dosing mechanism, whether it's water or air pressure driven, those solutions are also available. But the preference seems to be for tanneries to go for a much more manual, low-cost, easy-to-use mechanism as the one that you see on the screen there. Once the spheres are inside the drum, of course, they need to be contained inside the drum so that they are there for the full cycle of retanning and dyeing, and they don't flow out through the intermediary baths. And the mechanism for doing that, again, is very simple and low cost. The typical configuration inside of a drum with washboards, as I'm sure you will all have seen, consists of washboards with small holes that are typically a couple of centimeters in diameter. Now, of course, with the spheres being only 7 millimeters in diameter, they would flow out with each bath inside the drum. So the main change that is required at a tannery to use spheres is to change the washboards inside the drum. Now, this is critical because it's not changing the full drum. It's not replacing the drum. It's just changing the washboards inside the drum with new washboards that have smaller holes or slots that won't allow the spheres to wash through. And you can see on the screen there on the left-hand side, a wooden drum with wooden washboards. In the middle of the screen, a polypropylene drum with polypropylene washboards that have been changed to use spheres. And on the right-hand side, a wooden drum with polypropylene washboards that have been changed to use spheres. That change, once those new washboards have been fabricated, can be made to a drum within a matter of a day to a day and a half. So it does not result in significant downside in terms of production for the tannery. And also because the surface area of the openings through which the float flows through and drains doesn't decrease. In fact, with this new configuration of washboard, it actually increases. There isn't a negative impact on the drainage time for the drains of the drums. So a simple low-cost solution for modifying existing drums that can be implemented in the matter of a day or so. After the full cycle is completed, then of course, the contents of the drum need to be emptied, and then the spheres and the hides need to be separated. One approach for separating the spheres and the hides is to attach a grid to the door opening when emptying the drum. This allows the spheres and the final float to be emptied while retaining the hides inside the drum. That's one mechanism that tanneries have started to use. Equally, other tanneries prefer a mechanism where the spheres and the hides are emptied together into a container underneath or into a skip underneath, and then the hides are then taken out afterwards as they normally would be, and the spheres just fall off and remain in the skip. So simple, low-cost mechanism for separation. The key, however, is making sure that when the contents of the drum are emptied, then the spheres are contained and channeled into the skips or the containers that you see underneath the drum. Simple mechanisms for doing so. You see in the top picture here a steel screen. Here are textile-based or material-based curtains, as we call them. Both solutions work well. It really depends on the preference of the tannery and their production environment, what would be more suitable for them to channel the spheres and make sure they go in their intended location underneath the drum in that skip, rather than ending all over the floor. Simple, low-cost solutions for containing the spheres. And then finally, of course, when the spheres have been emptied from the drum, the hides have moved on for further processing. The spheres are mixed in with the final bath with some stringers and fibers, and they need to be separated from those stringers and cleaned, essentially, so that they can be used for the next cycle. There are different machines that have been developed to allow for that to happen. On the left-hand side, you see a machine that is for more of a continuous flow-based cleaning system. The spheres are cleaned in this container here, and then they're reloaded automatically into the silo. Equally, batch-based solutions are available rather than continuous flow-based solutions. The essence of all these solutions is the same. On the inside, you have some sort of mechanism like a vibratory deck that you see in operation, hopefully on the screen in front of you. And that mechanism separates the orange spheres that you see from any fibers from the final bath, so that the spheres can then be used again, put back into storage and used again for the next cycle. So that's the modular system, modules 1 through 5, from storage through to cleaning, that allows a tannery to use the solution at full scale for production. But what about the other two considerations? What about the cost? Is it commercially viable for a tannery to adopt such a system? When the system was first envisioned in 2017, the cost perhaps would have been prohibitive for many tanneries. So in 2017, the original system that was envisioned was estimated to be about 1.2 million euros. So as the system was developed over the next few years, and some of the more configurable elements were simplified, as you've just seen over the last 10 minutes or so, a key part of that simplification was also reducing the cost. So by 2019, the cost of the system had been reduced to about 350,000 euros for a typical tannery. And then further work was done between 2019 and 2021, so that tanneries that would be looking to introduce this new technology into their production today, depending on their specific scale and specific configuration, one would expect that the full configuration for an existing tannery could be implemented within about 50,000 to 150,000 euros, depending on their specific production volume and operational setup. Now that's really critical, because that means that the system can be adopted for a tannery with an initial investment that achieves full payback based on the efficiencies that they achieve within about 6 to 12 months. So that configured system that we've just shown for a typical tannery would achieve payback within 6 to 12 months. So now it's a lot more commercially viable than it would have been 3 or 4 years ago. But what does it mean for the operators themselves? Because working with spheres is a significant change from perhaps the way they've been doing things for the last few years or the last few decades. And initially, when operators are first introduced to the sphere-based system of production, they're typically curious, perhaps skeptical. They think it might be interesting. And even if they see that it's worked for other tanneries and achieved some efficiency benefits, they're not sure it will work for them, right? Their leather is unique, their leather is different, and it really has to work for their specific application. So the way to overcome that skepticism is to prove it to them, to demonstrate to them that it can work. And after it's been demonstrated and they see it for their specific tannery, for their specific leather application, for their specific chemistry, that also produces some concern, right? Well, it works, but how are we going to handle the spheres? How is it going to work when you have to dose the spheres day to day for 10 to 15 drums in large production scale? And they need support in making that next change, right? And that support is typically through working with them to work through the installation and setup of the system, but also providing training, because it is a significant step change to work with the traditional mechanism to work with spheres. There's been no exposure to spheres. And despite that, rather than the concerns being completely alleviated, you'll find after that concern actually grows after the implementation is done, because there's a huge fear of failure. Because now, after the operators have seen the system implemented, they're worried about having to own it. It's theirs now, and they're still concerned about how this will impact their production setup. So as an example, we're aware of a tannery where even after adoption and seeing through numerous demonstrations that the quality of leather could be achieved, once the operators had to run it in production themselves, they went back to their old way of doing things. So rather than reducing water by 30-35%, they started adding more water into the system, into the production drums, because they were worried that they wouldn't get the results that they wanted. And of course, by adding more water into the system, they were completely negating how the spheres actually worked, because the spheres rely on being able to deliver a much more concentrated float into the system. So that's a very natural fear that operators will have whenever they make a change to a new paradigm for working. And the way to overcome that is to provide them more support, ongoing support after they've started using the system, through continued training, through continued Q&A and addressing of the issues that they may be concerned about. And with that particular tannery where they were having that experience, over time, after a year of using the system, when you go and talk to their operators and you ask about, well, what's it like to use a new way of production, and how do you feel about the concerns that you had at the start of the process? After a year, they say, this is just how we do things now. And they consistently achieve the water savings and reduce the chemicals required, so that less of the chemicals go out in the waste and more of the chemicals go into the fiber structure of the hides. And that's just how they do things. So you may have heard about the sphere technology over the years and the potential benefits, but also been concerned about some of the practical considerations, but hopefully some of the challenges with the day-to-day operations, how the system will work, and the commercial viability of the system have now been addressed. And if you have any questions, would be very happy to field them.
Thank you, Vikrant. That's such a potential for a step change there in the way that we make leather. It's a really, really interesting technology. We're currently running about 20 minutes behind, but as I say, we have some flexibility at the end of the day. So I think we have some time for some questions. If people want to put some questions into the chat box, we can share them. I have a first one for Kim. Just briefly, Kim, how important has a specific life cycle analysis of the process at JBS been for your customers in terms of detail on your actual footprint and reassuring them that leather is a good product to use?
Thanks for the question, Carrie. Well, the importance, it really actually shocked us how much customers were in need of such data about our leather. At one point, we started, well, sharing the data and learning why they wanted it and they needed it so much. There are, of course, obvious reasons. They want a figure. They need to understand how it's positioned with their alternatives. But in the bottom line, all these big companies, they have commitments for decarbonization of their supply chains. They have KPIs, and the way they can achieve those and they can account for those is to have quantifiable metrics. So having a quantifiable metric about the impact of the leather we produce is a very valuable input for the companies to actually go to their net zero goals or to their science-based targets. So very much, and we are eager to learn, depending on the maturity of the company on the topic. Many of them get into deep discussions and want to learn more about it.
Thank you. Yeah, I think there's a lot to be said for tanneries producing their own data and reassuring their customers directly rather than relying on the data, which, as you pointed out earlier, is very, very out of date and very inaccurate. Thank you for that. A question for Rogério. What would you say are the sort of key differences on the CSCB system compared to other certification systems?
Okay, Gary, thank you very much for the question. Yes, I would say that we have three key differences among the CSCB and the other certifications. And the first one, I would say, which is is that CSCB's official scheme it is from the Inmetro, which is an official institute in Brazil. It's the National Metrology Quality and Technology Institute in Brazil. So it's different from private certifications. So, and it has also the tripod of sustainability, which is the economic, social, and environmental dimensions, also different from the ones that are only environmental certifications. And also the third one, the main key difference is that it is audited by third parties. It's not audited by the own Inmetro certification. It's owned by companies that are authorized, are registered at the Inmetro Institute to be to audit the tanneries. So these are the three main differences among CSCB and the other certifications.
Thank you very much. Two questions here from Vikrant from the audience. From Dr. Christine Anskill at Sautra. What would the typical reduction in water consumption be in the process?
So the typical water reduction in the retanning and dyeing phase is between 30 to 40%. We've seen for the demonstration that we've seen. There is, of course, variation from recipe to recipe, and there are some recipes which we've seen, for example, for an automotive tannery where they've reduced water by over 60%, about 62%. But on average or typical, we would say between about 30 to 40%.
Okay, and then a follow-up question there from Murat Tozen. Can this be used in the beam house where huge amounts of water are being used?
At the moment, we haven't focused on the beam house, so I wouldn't say no, but I also wouldn't say yes at this stage. It can be used in tanning, so tanning specifically from pickling onwards in the chroming step. But in beam house, we haven't really explored it significantly.
Okay, thank you. I just had a question on the Vikrant on just. Is there any consideration being given to the impact on the environmental footprint of the product from adopting polymer technologies with the association there with plastics, obviously, versus the savings in chemicals and water?
Yes, that's a great question, because obviously we don't want to have a benefit on the one hand and do harm on the other. So we have conducted an internal life cycle analysis. It still needs to be done more through a third party to allow for independent verification. But from our own internal life cycle analysis that we've conducted, there is a significant reduction in carbon footprint, particularly if you consider the impact of the chemistries that are wasted that go down into effluent stream. Now, if you didn't have to transport those chemistries and produce those chemistries, and you reduce that or minimize the impact of that, that has a very significant impact from that perspective. If anybody is interested in the specific numbers from our internal calculation, please email me and I'd be happy to share those with you. But yes, we have looked at that internally, Kerry, and over the next year or so, we would aim to verify that independently as well.
And then just one last question, I think, for Kim, which I think is relevant to all of us. The Centre of Excellence you discussed, I think, could be an extremely important development for the industry in producing the up-to-date information that we need. How do people get involved, and when are you looking at starting?
We are now, Kerry, putting together the necessary NDAs and documentation to create it. But as soon enough, and we will communicate. So as soon as it's ready for other companies or academia or anyone to engage with it, we'll make sure to make it public with a press release and invite everyone to join. Again, it's going to be a collaboration platform. The more, the better. So we want more people involved from different segments, from different specializations. So, and that we are confident on releasing these first communications between the end of the year or very early 2022.
Fantastic. So everyone keep an eye out for that. I think we've probably reached the point, Professor Hailemariam, where we should be looking at heading to lunch. So did you want to make any closing comment before we head out? Just like to take the opportunity to thank the speakers of that session. That was some really, really very interesting stuff there. Thank you very much.
Thank you. Thank you, bye.
I thank you, Dr. Kerry. Really, this was a great moderation, and we learned a lot from the presentations. We are very happy. At this stage, we are finalizing the morning session. We will break for lunch. Before going for lunch, we obviously acknowledge and thank all our sponsors, TFL, PITAT, JICA, Chromogenia, ATC, Brazilian Laser, Bachmann, and other two sponsors supporting the sponsors, Ethiopian Airlines and Delico. We are very grateful to them. We thank you. We will break for 1 hour lunch, and we will be back at 14:30 East African time. Thank you very much for your participation.